10.6 is starting us with our polar coordinates. At this point, you should have already read through that entire page and attempted to do all of these on your own, at least through number 5. I will be filling in some of the blanks and making sure you truly understand what you were supposed to. Starting with, here's our little polar coordinate graph. The point A can be represented by those coordinates 2 pi over 3 or 7 pi over 3. So notice the difference between the two is with their theta, because you are using that format of r theta. And we do typically put our polar coordinates in brackets like that. So the r represents your radius. So looking at point A, it is on the second circle away from the center, so its radius would be 2. It is actually lined up on that pi over 3 there. Pi over 3, so coming to that angle, is equivalent to if I went all the way around, so 2 pi plus pi over 3. So that's where you get the 7 pi over 3. Those are coterminal angles, if you recall back from chapter 4. So it doesn't matter which one I use. Now, preferably, I probably would use the pi over 3 because it's within that first revolution, but both would work. Or you could go around a third time, fourth time. You could go around as many times as you want. You could also go around backwards. So if you look at point B, it says it can be represented by the coordinates 2. So again, it's on the second circle away, its radius is 2, negative 7 pi over 6. So it's coming from that x-axis at 0 all the way past your pi here up to what would be 7 pi over 6 if I was going in that direction. So that's negative 7 pi over 6. It says to be using a positive value. So if I went my normal counterclockwise direction, and I can see, oh, it lines up on that 5 pi over 6 angle. So the radius is still 2, but my angle would be 5 pi over 6. You could do similar to what we did in number 1 and go around multiple times if you wanted to. But if I'm only going to ask for one, probably the simplest one, or the one that you come to first. For 3, we're actually looking at point C. It has the coordinates 3, 5 pi over 4, as well as negative 3 pi over 4. So I want to look at each of those. So 3, 5 pi over 4. So if I look at 5 pi over 4, that would be this angle right here. And I am on the third circle in that direction. 1, 2, 3. So that's how I get that angle. For this negative 3 pi over 4, I'll look over here at my pi over 4 spot, and C is not in that direction. It's going the opposite direction. So almost like if you were facing the pi over 4, but now you're going to go, instead of that direction, you're going to go backwards. 1, 2, 3. And it still lands you in the same spot. Give 2 different sets of polar coordinates for point D. Make sure one set has a negative radial value. So first off, looking at D, it is on 1, 2, 3, the fourth circle. So essentially I know one of mine can have 4 for R, but the other one needs a negative 4. Try doing those if you have not already. If I'm going to use this positive radial value or positive number for my R, kind of like my radius here, then I just want to actually say, well, what direction is it? Oh, it's lined up with 0 or 2 pi, either one. So when you use your positive R, you are truly reading it off of the graph. The exceptions being if you wanted to do a negative for your theta, or if you wanted to go around multiple times. But if it doesn't say I have to do anything fancy like that, I'm not going to. Now I could have said for 2 pi. That would be going around more than once, or technically going around at all. Or I could have said for negative 2 pi. That would be going the opposite direction. All of those would work as point D. However, it does ask for one that has a negative radial value. So that -4, when you're doing your negative ones for the r, you actually want to look at what's on the total opposite side. So completely opposite of where d is pi. So if I was facing towards my pi at the center, but instead of going towards it, I went -4, I would still land at d. Now with that, to get equivalent to being at pi, I could say -pi, because that would be going the negative direction. Again, if I wanted to keep it still with that -4, and so basically I have to make sure it's lining up with this pi, I could go around more than once, so that would be 3 pi. All of those would be equivalent. I would say these right here would probably be the first two that you would list, and the two that I would expect the most. When you're doing these on number 4, you need to have one that has a positive r and one that has a negative r. One that has a positive theta and one that has a negative theta. Go ahead and try these. I'm going to pull a couple to talk through, and then I'll throw the rest of them up. Note that when I put my answers up, they may not be the ones you gave because there's an infinite number of options. I'm giving what I would expect to be the first two you would list. With v, if I'm at 6 and pi over 2, say I want to keep that 6, but I want to go the negative direction. If you need to, draw your unit circle. Pi over 2 is up here. If I go that negative direction, that would be -3 pi over 2. That's the same as, let's say, if I did a -6. So I'm going to keep it with my negative radial value now. So I wanted to be up here, but if I'm giving a -6, I actually need to tell you what that angle down there is, so that you go the opposite direction of it. And that would be 3 pi over 2. Check some of these as you're doing them. Again, if I list one that you don't have but you think yours is right, you very well could be right. If you're not sure, just ask me in class. On this one, it's a little bit weird on why, because I've already given you that negative value, so I truly haven't given you the actual angle. If you think about this, 3 pi over 4, oops, there's my 4s, would be right here. But I'm doing negative, so I'm actually coming over here to what would be 7 pi over 4. So you could tell me, oh, that's 7 pi over 4. Because that gives me my actual angle that I'm going and the actual distance from the center. If I'm going to keep it as the negative one, because I did want you to write one where it had one positive and one negative for that radial value, the other way to write 3 pi over 4, instead of going your normal positive direction, go in your negative direction. That would be a -5 pi over 4. So both of those can be negative. That's totally fine. Again, any of these that you're not positive you did correctly, because they don't match exactly what I have, there are several different options. So just check them with me if you're not sure, or graph them on your graph that you have in the front of that page. Make sure on number 5 you have some sort of sentence there explaining why you can identify any point in the polar coordinate system with an infinite number of coordinates. The next thing we're going to look at is your coordinate conversion. So going back and forth from xy to r theta. So first off, x is equal to r times cosine theta, which makes sense. We've always had x going with cosine. So from there, hopefully you can infer that y is equal to r sine theta. your theta, so I'm looking at it from the opposite direction, like it has always been, chapter 4, 5, 6, is tangent inverse of your y over your x. And your r, we're actually going to define using r squared, just like we did in chapter 6, is x squared plus y squared. I know a lot of times we said it was the square root of those. It does not matter here, but that relationship is the same. So these are how I'm relating my x's to my r's and my thetas, or my thetas and my r's back to my x's and my y's. So for number 6, it says convert the polar coordinates to rectangular form. So I have it says polar coordinates, which they stopped using brackets, but as r theta. So I need to rewrite this using x and y. I know that x is equal to r cosine theta. So I'm going to just plug in what I know. My r is 3, my cosine is 3 pi over 2. Which, if I think about my unit circle, cosine of 3 pi over 2 down here is at 0. So my x value is 0. For my y, it's r sine theta. So again, my r was 3, my theta was 3 pi over 2. Thinking about my unit circle again, sine of 3 pi over 2 is negative 1. So 3 times negative 1 is negative 3. So my xy coordinates would be 0, negative 3. Try that same thing for b. You should get negative 2, 0. On number 7, we're converting the rectangular coordinates back to polar. So again, you have your rectangular, so you have your x and y. You are trying to go to your polar coordinates. One thing you want to think about here is which quadrant this is going to be in. So negative 1, 1, that helps. Graph it, right there, is in quadrant 2. So theta equals tangent inverse of y over x, so 1 over negative 1, which I should know from my unit circle because this is on my unit circle. But I'm going to get, if you type it into your calculator, a really ugly decimal because you're going to be in radian mode. But don't forget that your calculator will only ever give you that reference angle. So it would actually give you the equivalent over here in quadrant 1. But because I've already listed that it's in quadrant 2, and I'm not being lazy and looking at my calculator, I'm actually thinking a little bit, I'm more likely to get it correct. And I know that it's in 3 pi over 4. For r, again, you could do r squared equals x squared plus y squared, or if you want to go ahead and rewrite it as the square root of x squared plus y squared negative 1 squared is 1, 1 squared is 1, so this is the square root of 2. So my r is the square root of 2, so my polar coordinates become radical 2, comma 3 pi over 4. Try b. I got 2, comma pi over 2. With some of these, it's really quite simple to do just by looking at the graph. Like if I'm going to graph 0, 2, I can tell right there, oh, that angle is up at pi over 2, and it would be 2 distances away from the center. However, as we move into tomorrow's stuff, the next part of 10.6, you will have to be able to do these conversions because you're going to be doing them with equations instead of just points.